Hello, engineers, and welcome back to the DevSecOps series. So, today, what we are going to learn is what I have discussed in a lot of previous videos regarding. So, it is a really important topic that you need to learn, which is related to RASP, runtime application self protection. By this time, whatever we have learned is really, something which would not run in production with our application. But this thing, RASP tools are going to run in your production application with along as a sidecar stuff with your application. Okay, in the production environment. That is the really important thing that you need to know. One more thing that I would like to emphasize on is the background images of whatever the uh, slides that I make. So the way the background is set up is a very thoughtful process that I go through in terms of what should I keep it over here. So you should see by looking at the background only, you should realize that this is a security personnel who is standing in front, okay, of you. So now you are going into the application. Let's say suppose this tunnel is a on the end of your tunnel is the database, the application, or the details that you want, but you need to pass this particular person. Okay, so once this image I mean this person is, consider him as a terminator. Okay, so what it does is like it always adapts to whatever kind of attack you are kind of going to do. So this is a really important thing that should give you the understanding, or it should serve as a reminder or a revision for you. Like by looking at this image you should get the entire concept. So a lot of talking about the background and thoughtful thinking. Let's delve into the actual concept. So what is a RASP? I'll just these are the topics that we will be learning for today. What is RASP? What does RASP do? How RASP works? What are the benefits, limitations, popular RASP tools? And then at the end, there would be a comparison between WAF. Okay, WAF is Web Application Firewall versus IAST versus RASP. So, what is the difference between all of them? So this is the thing that we'll be looking at. So let's really begin with the last stuff. Okay. So what is RASP? First of all, you need to, I mean, whenever you go into an interview, okay, so this is the general way that you should move ahead when explaining about the topics. So that is the reason I always give you this topics list in a kind of format that you should be saying it in the interviews. So really start from explaining what is this thing, what it does, okay, and then how it works, and what are the benefits, what are the limitations, what are the different tools, and then comparison between this tool versus that methodology. So that is a general way of explaining a certain thing. So I know you really have a minute or so to explain it in interviews, but it would really help you in that certain cases. So that's the reason this particular format. Okay, let me. So RASP is a security technology. Okay, that protects application by monitoring its execution in real time and blocking attacks from within the application itself. So I'll explain it in a bit. Let's also read the another stuff. RASP integrates security controls directly into the application's runtime environment, allowing it to detect and prevent malicious activity, code injection, and tampering as it happens. So RASP is a real-time threat blocker. Okay, this is the really important word that you need to emphasize on in your interviews, or you should for your understanding. It is a real-time uh, active detector or monitoring solution, and then it again blocks as well. So remember in IAST, what was happening? There was a DAST application, DAST scanner, sensors were there, and then they were attacking your application, and it was only giving the information of how attack occurred and where it occurred to your dashboarding solution. So there was no preventive measures taken by the IAST application. It was also done in only QA environments. But now here you could detect it, I mean, whenever the attack is happening in the real time, and then you can also block it at the same time. So imagine you went to invade in the application, you tried to hack it, but then there was this agent that we had, who came in between and then defended the attack and then blocked it, and then further it learned the pattern, and then it stored the information, and whenever now you try to attack the application in the same way, would by default have this protection layer enabled. So that is the really main, what we say, feature of this particular application, okay, or this particular methodology. So that's why it integrates this security controls into the application and then it does all these things. So I hope you got the point. Okay, by now you should be really well versed with whatever the security terminologies we are using, and what is the end goal that we want to achieve. We want to achieve our applications from getting tampered or attacked. So then comes what RASP does and how it does it. We would see in the next one. So RASP first of all monitors the application behavior in runtime. Okay. It keeps track of how the application executes, how inputs are handled, and what external calls like system or network calls are being made. So you remember whenever an application is running, it runs on a certain system. Sorry, Mike. So then there are any network communication that it does from its application endpoint to APIs to any other external APIs. Again, sorry, Mike. So this RASP application monitors all these things and it keeps track of how it works. And then again, once it finds any kind of attack is being made, it would generally detect and block the attacks instantly. So unlike firewalls or scanners that sit outside the application, RASP works inside the application runtime, which means it has full visibility into the application's logic, data, and execution. So it knows whatever goes in the inside, and then it helps you attacking. So consider them, I mean, RASP as a WBC. So WBC is there in your body, white blood cells. Okay, also in layman terms, call it your immunity. So immunity knows how your body functions, where what is going on, the blood is flowing in which direction. Okay, is the blood pure or not? So this immunity would have the full visibility of whatever goes inside your body, and then if there is certain virus or any bacteria that enters your body, it does what? It adapts to the other end. I mean, how it should defend this particular virus. So it contains it, and then it further learns the pattern and then blocks the new upgraded version of the same kind of virus. Let's say if it somehow enters your body, if it is not able to do that thing, then it would trigger certain alarms, and then you would feed certain inputs. In the case of COVID, so it was a new virus, then we decided any new vaccine, and now your body has adapted the way to create this particular antibodies for the COVID virus. So that's how it works in the nature, but for your application you have to develop it on your own. So RASP does that particular thing for you. So I hope you remember, you understand the gravity of the uh, help that RASP tool will provide if you are running a really critical application. I'm not talking about any uh, time pass application like weather forecaster. I mean, weather forecaster is also a good application. AQI indicator is also good. What time pass application? Hmm. I mean, a lot of application. Let's say a gaming application. If a gaming application contains any payment gateways, it would help in this way. Okay, so that's one thing. Then it protects against common vulnerability, so SQL injection XSS, then command injection in secure API calls, and a lot of different terms. So these are the stuff that usually the application have, or world is aware about this kind of attacks. So Then next, how RASP works. It is usually deployed as a library, agent, or plugin inside the application. Okay, inside the application or the application runtime. So there are two ways usually to do these things. Then when suspicious activities is detected, RASP can do the following things. It can block malicious inputs. It can terminate the execution of request or the user session. So see, if someone tries to attack you, it could directly cut off the request. If it detects it in the request payload itself, it would kind of stop it in the between, or it could terminate the user session. I mean, you would directly be logged out of that system. So that is a really powerful thing to do. Then alert security teams, if they the alerts are configured, and then log detail context about the attack, how it occurred, where did it originated, it would keep that track. And then shuts down the application to prevent further damage if it requires. Okay, if it thinks that the DDoS attacks, SQL attacks are simultaneous, or any quantum computing is attacking, a bot control is doing that attack, so it would completely shut down the application if you have configured it in that way to prevent any critical damage or loss of information. Okay, so that is how it works. And then what are the different benefits of this particular RASP stuff? So application level security, it really helps your application from the inside, and then offers more granular control than external network based defenses. So today there is a lot of cold in here near my surrounding, and having a bit of cough, so that's why I'm doing this. Don't worry about it, I'm good. So it helps securing your application from the inside. अदरवाइज सम पीपल से अरे भाई आज जैकेट पहन के बैठा है, कुछ तो स्पेशल है। नहीं भाई, ठंडी बज रही है, इसके लिए वो जैकेट पहना हुआ है। ओके, देन द बेनिफिट ऑफ the RASP is that it is context aware and it understand how the app works. Unlike WAF, WAF is what, web application firewall, and it sits outside of your application, and it would just look at the network traffic and see or block certain kind of headers or requests, payloads, or certain IP or certain geolocations. So WAF is an outside stuff. But if someone could bypass the WAF, it could hamper the application in that sense. There is certain masking of the payloads or any files that could be sent over the network. So WAF only sees traffic but cannot do anything explicitly if something else occurs. Then zero day attacks. Okay, then zero day attacks are what, it acts fast if any zero day exploit may have bypassed other security measures. So if something which was not known earlier, it appears and the hackers are aware about it, and then your other systems are not able to detect that thing. So this way, RASP would do the stuff on it, and then it would prevent the attacks as well. Then accuracy, so reduces false positives compared to traditional security measures. So remember, IAST implementation and RASP implementation really helps you in reducing the number of false positives in your vulnerability mitigation procedure. That helps a lot. Then real-time protection, it works with the application inside production environment. This is the main stuff you need to always remember. Production environment is the key. Real time and then production environment, these are the two of which are really important, then which gives application more security whenever it is served with the to the customers. So and then automated response, RASP can automatically block threats without requiring human intervention, which is beneficial for organization with limited security resources. So imagine one person can also handle the responsibility of securing your application if he knows how to deploy RASP solutions. Okay, if he doesn't need, I mean, know that thing. If you don't know that thing, it would not happen. What are the limitations? We have talked about the benefits, how it works, and why it is helpful. But let's say not every solution is really good for all of the people. Okay, so there are certain limitations to it. Nothing is absolutely very good. So RASP is having three different cases with it. So remember, in our previous video regarding IAST, I mentioned something that as the complex, I mean, as the accuracy or the result giving probability of any tool increases, the integration complexity also increases because it requires access to all of these things, the APIs, the code base, to the runtime environment, to the configuration of your environment, to the network configuration, okay, to the infrastructure packages. So it requires a lot of integration related stuff. So complexity increases as the security tools level increases in the hierarchy. So SAST is easy, SCA is easy, BAST is a bit complicated to apply, IAST is a bit more complicated, then RASP is again more complicated, WAF is a little bit complicated than other things. So that's the hierarchy of integration complexity as it reaches ahead. And then team resistance. So RASP's real-time analysis can slow down application performance. So if it kind of goes into a loop back of blocking all the requests, if there are certain kind of attacks, then it would really slow down the application performance in this sense. So it has to first detect the requests, then analyze them, and then only it would pass it ahead. So this way, the analysis can slow down the performance of the application. Okay, so that is really major stuff. It would cause in delays in uh, attending to the request or giving response to the clients. But you should go for it in case if you have really critical application. I don't say that you should all go in with RASP or IST. It is heavily dependent on the type of uh, criticality of the application or the impact it may cause to your consumers. So adding RASP to an existing system can be tricky. It may cause integration issues with legacy systems, as I told you already. Uh, it would have really complex stuff if you try to use it with older uh, tech stacks. Then conflict with other security tools, improper tuning leading to false positives. So you also need to somehow keep track of the stuff, or you have to train your application as well, which we certainly call as tuning. Uh, so if there are any misconfigurations done, then it would result to false positive or false results. That could be adding noise in your remediation efforts. Then team resistance is one more thing. It requires collaboration across development, security, and operation teams, which can lead to resistance to change in established workflows. And then concerns about adding complexity, disagreements on security versus performance trade-off. So it have a lot of discussions way ahead on that front. So I hope you grasp the gravity of these things. Uh, I'm really having a cold right now. Then what are the different popular RASP tools? So Imperva, Micro Focus, JS Defender, Screen, Contrast Protect, Veracode Runtime Protection, Immunio, K2, App Sealing, and cybersecurity application protection. You can look at all of these different popular RASP tools, and you can also try out using some if they are free. You can try JS Defender, uh, try it, or else you can apply for Veracode runtime protection for a certain period of time. I guess so. I have not done it personally, but you can have a free trial, let's say for 2 weeks, if I'm not wrong, 14 days. So these are the tools that you should know. And then finally comes the point wherein you should really need to be aware of whatever the comparison of RAS versus IST versus WAF is there. So let's see how it works together. So WAF, I mean, we will look at these different features. So purpose, locations, page of use, visibility, and then action. So where these applications are located. So first we will discuss about WAF, web application firewall, interactive application security testing, and then RASP. So purpose of WAF is to block malicious request. Nothing else apart from that. Okay, web application firewall. Firewall is all about network related activities. So where it is located, it would be outside the application, in which phase it would be on the network layer. Okay, sorry, not phase. It would be on the network layer. Then what is IST? IST would find vulnerabilities in testing phase while it is interacting with your application, combining SAST and DAST. So it would be there in the application, but only on the testing environment. You would not deploy nahi, deploy the IST solutions on a production environment. But for RAS, it detects the threats and attacks and then blocks the attack in real time. So it is a live security guard for your application, and then it is working in the application itself, inside application, in the runtime environment or the production environment. So that is really the most important stuff for an application, critical application. Okay, so that's about the difference of purpose and location. Then at what stage you can use what application. So here WAF you can use on QA environments, pre-production environments. Okay, and also production environments, because you would require WAF majorly over there as to block the malicious requests. Then deployment and production for IAST. Okay, you can have them there both. Earlier I mentioned that you would not deploy IAST on production if you also adapt RASP. Okay, so IAST is fine for QA and test environments if you go with RASP solution. Otherwise, if you don't go with RASP solution, you can have it on the production environment as well. So that is a catch. So if someone asks you in the interview, okay, so what are the things that I could do to secure my production environment if I don't have to go with a runtime application solution? So here you can say WAF and IST both could be there on the production environment if we are not going with RASP. But if we are going with RASP, you could trade off WAF and IST instead, and then we can only have RASP. But it is a good practice to have defense in depth. So you would go for a WAF and RASP on production environment to have best security controls for your application. That is how uh, a diplomatic answer would be for that particular question. So I hope you got the point. Then visibility. So WAF would have only visibility to the requests that are incoming to the application, towards the application. So that's what it have. And IST and RASP solution have the visibility for the code as well as the runtime environment. So here it would have in test, and here it would have in production. So that gives you a good edge in product protecting your application. Then what are the actions? So actions would consider blocking. uh, just a second. It would block or allow traffic, the WAF, and IST would only report the vulnerabilities, as I mentioned, to a dashboard solution that it has for that particular vendor. But RASP will directly block the attack instantly. So a major benefit that you can see over here. So I hope you got to understand these particular points that we have covered. Now at the end we have this thing which we already have seen a lot of times. So now we have covered RASP. Here I think I should mention MAST as well. So yeah, threat modeling, SAST, SCA, DAST, IAST, RASP, and MAST is covered. We will again look into the other methods, secret management and container security and infrastructure as code security, in our upcoming videos. And also some of the dash hands-on videos is what we are going to see. Also how to secure your containers when you are kind of building them. So let's wait until then, and see you guys in our next video. And yeah, one more stuff, if you like this particular video, then share it with your contacts, I mean the people who are getting into security and all this stuff. And like, share and subscribe this thing, blah blah blah. So that's it for our today's video. Let me know what your thoughts, comments are, and whatever other questions you might have in this matter. For practical applications related stuff, we would meet in our another sessions, but this series majorly would focus on your core first. okay, which is the theoretical part. Then we would go into the hands-on practice for all of these tools. Like learning tool is a matter of 2 or 3 days majorly, but learning the concept is really more important that I focus on. So that's how it goes eventually. So that's all for today's video for the runtime application security, self protection. Sorry. So see you in our next videos. Until then, keep learning, guys. Bye.